Hello, good morning my dear students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. So this is one short series, Chemical Bonding, board say NEET Tech. How are you all? So happy to meet you once again in the YouTube studio from Infinity Lane. How are you all doing? Please confirm, can you all able to hear me? Can you see me? Right. Shoaib Chowdhury, hi. Good morning. So let's talk about chemical bonding. So this is the topic where it is completely connected with boards, NEET, whatever the competitive examinations you are writing. And also it is connected to inorganic chemistry, organic chemistry and physical chemistry aspect as well. So when it comes to the bond energy and bond parameters, it's connected to thermodynamics as well. Hi Sonali. अभी बताओ कहाँ से? मैं आप मध्य प्रदेश से आए, मैं हैदराबाद इन्फिनिटी लेन यूट्यूब स्टूडियो से. Okay, anyways, let's welcome this session, chemical bonding and molecular structure, and this is the topic from the grade 11 NCERT, and it is connected to all P block elements and D and F block elements and other parameters, and we will be connected to the organic as well. Jahri, hello. I'm fine, thank you. Please, those who are online, please like the session and look at this. Chemical bonding is such a topic. It is connected to all CBSE preparing students, and आज का session जो है ना one shot में total chemical bonding आपको पढ़ाना वाला हूँ, and take a pen and paper and write noteworthy points and simple tricks and tips भी आपको देना चाहता हूँ मैं. And this session is useful for the grade 11 students, grade 12 students and the droppers भी है. आज दो सा गया, so no, only academic के बारे में discuss करना. So without any delay, let us directly jump into chemical bonding, and there are so many topics and so many historical aspects are there in the chemical bonding. We will be discussing line by line from the NCERT book itself, right? And let's find out how the questions can be asked. And you see, this is the image. I like it much. You know why? Because it's a collection of dots, and these dots are connected. When you connect a dot, and you're going to get a beautiful picture. Similarly, when you are preparing for something, you study subject, you'll understand one point, and you understand another point, and you understand many points. But the thing is how you are connected to all the points in order to know the vast subject in the chemistry. So this is a symbolic representation that I want to give you. This is an awesome picture. I like it, and it has its meaning, right? Thank you. And let us go into more details about various compounds are there. So why we are talking about chemical bonding? Coming back to in the chemical bonding, what is chemistry? Somebody people say, what is chemistry? One of my students says, sir, chemistry is a study of all exceptions. Yeah, it's a weird answer, but it is true. Why exception comes? And dear children, when you prepare for NEET examination, you try to understand what is the reason behind the exception, isn't it? So don't go blindly and by hearting these exceptions and all. And connecting to chemistry is a study of chemical reactions. In a chemical reaction, reactant product बनेगा. ये reactant में क्या है? एक molecule शायद हो सकता, and old bonds in the molecules are there. ये पुराना bond जो है ना, ये break करके ये नया bond बनाना है, ये product बनेगा. So you need to study the nature of a bonding, ताकि आपको पता होना चाहिए chemical bonding का fundamentals. ठीक है बेटा? Lattice energy directly proportional to the charge, inversely proportional to the size. Of course, we will be discussing about that. And we know the periodic table. In the periodic table, various elements are there. When these elements are going to combine, they are going to form different compounds. You see, sodium chloride, calcium carbonate, and iodine crystals, and aluminum metal wire. And what makes these substances are made as a result of the chemical combination. So, मेरा सवाल है कि why do the elements participate in the bonding, right? So in that I just want to say in the chemical bonding, the attractive forces between the atoms bring together a stable entity. Atoms as such, they are not at all stable. Once they come and join together, they form a bond. And the attractive forces that makes the atoms stay together is called a bonding. And this kind of bonding, you see, a chemical bond is formed in order to increase the energy, increase the stability and decrease the energy. You know one thing, energy and stability, universal fact, stability is inversely proportional to the energy. So atoms of different elements participate in the bonding to decrease the energy and to increase the energy, to increase the stability. Today is your birthday, happy birthday to you, and you celebrate your next birthday in a premium medical college. Talking about and chemical bonding का ये graph क्या है? This is a self-explanatory graph, and you are going to see a question based on this. When a graph is given, you are going to see your y-axis and here it is an x-axis. X-axis में क्या लिखा? The distance between two atoms, and y-axis में लिखा energy का है. And you see the atom and atom between these two 300 picometers, so it's long away. When it is away from the infinite distance, they are free atoms, there is no attraction forces, there is no repulsion forces. So free atoms का energy ज़्यादा होना चाहिए. And when the atoms are bring together, attraction forces are greater than repulsion forces. So that what will happen, there going to be a bond between the atom to atom. So there is a situation which the minimum point of energy can be seen, and there you can see attraction forces are equal to repulsion forces, ताकि ये दोनों का बीच में bond होना चाहिए. The moment the atoms bring together here, it is going to increase the energy. Why? Because the nucleus of the atom and nucleus of the atom बीच में repulsion शुरू होता है. So this is a sigmoid curve where you can see the formation of a bond, and this is what is called as a bond distance. So that Drago's rule भी आज पढ़ाना है Sonali, and right now based on this we will be discussing so many things here. If you have any doubts, please let me know. So moving ahead, we have various types of bondings, and what makes the bond? The bond may have the various categories. You have ionic bond, covalent bond, and a metallic bond, are the three types of bonding. Apart from this bonding, we have the intermolecular forces as well. We'll discuss everything. Stay tuned, take a note and write all the noteworthy points, my dear students. Duration, आज session 3 घंटे का है. So please stay tuned, and one shot में सारे के सारा session का concept भी आपको delivery किया जाएगा. And you see ionic bond, this is a formed between electropositive element and electronegative element. By looking at that, we can say two elements, you can look at that and you can say which type of bond that can be formed. And covalent bond, it can be between two electronegative atom, non-metal के बीच में होगा. Ionic bond, a metal and non-metal के बीच में होगा. And metallic bond, two electropositive atom के बीच में होगा. We'll discuss simply about how ionic bond is formed. ये नमक क्या जैसा है? Students, here this is a common salt. What makes the bond between this common salt? And let's see here, ionic bond. The electrostatic force of attraction that holds between a cation and an anion. मान के चलो, this is a sodium plus है ना, and this is a Cl minus है ना. So there is an attraction force that hold between these two. That attraction force is actually called as ionic bond. If people say the bond is formed between complete transfer of electron, that is So bachcho, moving ahead here I just want to say formation of ionic bond. Elements involved in the ionic bond should possess two categories. One, the element losing the electron should have a low ionization energy. Factors favoring ionic bond formation. You have a cation, you have an anion. Let's see the formation of a cation, and after this let's see the formation of an anion. In contrast to that, in the JEE or NEET examination, you will be having a very good number of questions over here. So it should have a low ionization energy, large size, and low ionization energy, and low charge on it, bus. And better you have two types of electronic configuration beta. One is pseudo inert gas configuration, another one is inert gas configuration. So don't worry about that. जब 8 electrons वाला है ना, that is called inert gas configuration. जब 18 electrons होता है ना, that is called pseudo inert gas configuration. So the cation with the inert gas configuration can be easily formed as compared to cation with pseudo inert gas configuration. When it talks about the anion formation, na, contrast to this, if you form a large sized cation here, it should be a small sized one. And you see low ionization energy, it should have high electron affinity bus, and it should have the low charge on it. So these are the basic criteria you need to understand, and ये basic criteria का हिसाब से आप आ सकते हैं कि इतना आसानी तरीका से कैटायन बना सकते हैं and anion बना सकते हैं. The way it is forming a cation, the ease of formation of a cation, the ease of formation of anion is going to be a very important questions for your competitive examinations, bachcho. And you see, it should have low ionization enthalpy or low ionization energy. Isomorphism, I am going to show it. And large difference in electronegativity of two elements. अगर जो electronegativity difference En बोलते हैं ना, it should be greater than 1.7 ताकि दोनों का बीच में atoms का बीच में ionic bond आने का संभावना है. Okay, unseen documentary. Hello, first you say hi to teacher, then you can say hello to Sonali. That is not Sonali, that is Anuj Gope, is from Madhya Pradesh. Okay. So moving ahead, the element accepting electron should have high electron gain enthalpy and also high lattice enthalpy between two ions. What is lattice enthalpy? I am going to show you that as well. Now my dear students, so this is about the ionic bond, and I will talk about the covalent bond, and we go into the details about each bond and the theories behind that. So stay tuned here. A covalent bond is formed by mutual sharing of electrons. Just like hydrogen एक electron देते, hydrogen और एक electron देते, दोनों का बीच में एक pair of electrons being shared, and this is called bond pair of electron or shared pair of electron. And a covalent bond, this is what is called a covalent bond. You have the coordinate covalent bond. Now everybody will ask you, how do I know coordinate covalent bond? Covalent bond present in Italy, white. Nice funny comments. Children, so moving ahead, how do I know? Electrostatic force of attraction between the metal kernel and the valence electron. That is a kind of bonding that is present in the metals. What is the metal kernel and a valence electron? This is how a bonding is seen in the metals. So we have seen three kinds of bonding. One is ionic bond, another one is a coordinate bond or covalent bond, and also we have seen the third type of is called a metallic bond. So bachcho, those who are online, please come on, stay tuned and learn the content that I am giving you guys. Now moving ahead, I just want to say, whenever you are preparing for something, you need to know where exactly you stand. For that, NEET test series is given by Infinity Lane, and this is separately prepared for 11th standard and 12th standard repeaters को भी है. Okay, and this is prepared by the eminent faculties from the content department beta, and it is based on the latest NTA examination pattern, and it gives you the real-time simulation of your NEET examination. It's an outstanding product. In the link it is given in the description box. You just watch this link and you try to explore, and you want to purchase, you just use YouTube 30 off कूपन कोड ताकि आपको 30% डिस्काउंट मिलेगा. बच्चों, this is a very important assessment platform. You just go ahead with that. A short promotion. Okay, moving ahead, I just want to talk about a metallic bonding here. So what is a kernel? Nucleus plus inner electron is called a kernel. And what is a valence electron? The mobile and the free electrons. Okay, hi Gupta. This session is for 3 hours. Okay, let us 2 बजे तक करेंगे. You want me to take a longer session or a shorter session? It all depends on you. And you just keep talking to me, you'll understand. If this is an atom, bacho, in this atom, this is the nucleus and the inner electrons, and this is called kernel, and this is called kernel, and that is called outer electrons. In that metal, the kernel electrons are going to be immobilized and the valence electrons lost, and these valence electrons make the bond between the atoms of the kernels. So that is about the metallic bond. We'll come back here, band theory and all. Talking about the lattice energy, what is the lattice energy? It's very, very important. Now we are into the hardcore thing. Energy required to completely separate 1 mole of solid ionic compound into its gaseous constituent ions. You see here, sodium chloride is ionic crystal. It's a solid. When you give some energy, it is going to be converted into its ions. So the energy is known as lattice energy. Are you getting or not? That energy is called as lattice energy. And this lattice energy, AB is converted into A plus and B minus, and lattice energy is going to be positive. And if you reverse this, is going to be the negative. So delta H is going to be positive here, delta H is going to be negative here. I just want to define here. So NEET examination में definition का हिसाब से questions भी आ सकता है. The amount of heat liberated when 1 mole of ionic solid is formed from its constituent gaseous ions is called as lattice energy. ये भी एक type of definition होगा बेटा. हाँ, NEET के लिए questions भी हो सकता है. Yes, Monica Gupta. Yes, we'll discuss all the things. So these values will be given, and you have to identify exact meaning of this. Then only you can pick the right way of picking the MCQs. So there should be a technique when you prepare it, and stay tuned for the technique, and I am going to give you the best out of it. Bacho, so in this winter, take hot water and stay healthy in the class. Okay, because this preparation time is very important, and we are also experiencing too cold weather, and throat problem is there, and please bear with us if any inconvenience caused during the session, and stay tuned for you. I don't want to disappoint you, make you to the best of the class here. And factors affecting the lattice energy. Lattice energy, जो energy है ना, that makes these two ions together, and more the lattice energy, stronger is the bond. Okay, that is the key point. Here, lattice energy is directly proportional to 1 by R. So Anush, you are saying correct. And Monica Gupta, you see, R plus and R minus together, sum of these cation radius and anion radius is said to be the radius. Radius means inter-ionic distance. This is a cation, and this is an anion, and this is what is called as R plus, and this is what is called as R minus, and together it is said to be R. I wanted to say lattice energy is directly proportional to charge on the cation, charge on the anion. So lattice energy is inversely proportional to inter-ionic distance. When it comes to the charge, when it is come to the radius, which should be taken into the priority? I want to ask a question. So it is a live interactive session. You can talk to me and you can say exactly. So when it comes to the lattice energy, charge is given the priority number 1 and radius is given priority number 2. So charge is the deciding factor. You see, lithium fluoride, magnesium oxide. Radius is 2.01 and the magnesium oxide radius is 2.1. So ये दोनों बराबर दिखता है, लेकिन इसका जो चार्ज है ना, चार्ज ऑफ द कैटायन +1 -1 +2 and -2. So it is going to be 4, it is going to be 1. So its value is going to be 3933. Please don't memorize the values. आपको convince करने के लिए ये values दिखा दे रहा हूँ मैं. And charge is the deciding factor. So the lattice energy is directly proportional to Z plus dot Z minus, charge on the cation and the charge on the anion. So these are the tricks that can crack you questions in the NEET examination. So whenever it comes to the NEET examination, so students preparing for NEET examination, when you look at the heading lattice energy, you will just afraid of it. Darna mat beta. So charge is there and lattice energy inversely proportional to the interionic distance. And a modular equation is given and modular equation, and you just go into the confusion when these equations are seen. Just see the proportions, constant निकाल के. ठीक है बेटा, अच्छा तरफ आपको देना चाहता हूँ. So when it comes to the radius and the charge is the priority. Moving ahead, charge is the deciding factor. Moving ahead, order of lattice energy, as said here, Ki, Kbr, Kcl and Kf. Here, charge is the same. When charge is the same, radius is the deciding factor. So, जिसका radius कम है, lattice energy inversely proportional to the radius. जिसका रेडियस कम है उसका लैटिस एनर्जी ज़्यादा होना चाहिए. फ्लोरीन कम से कम एटॉमिक साइज होगा ना, एंड इट इज़ गोइंग टू बी क्लोरीन और बड़ा है और ब्रोमीन और बड़ा है, आयोडीन. सो एनायन का साइज, क्योंकि पोटेशियम इज अ कैटायन कांस्टेंट दिख रहे हैं एंड एनायन बढ़ते जा रहे हैं एंड रेडियस भी बढ़ते जा रहे हैं, लैटिस एनर्जी कम आ रहा है. आर यू गेटिंग और नॉट? दिस इज द बेस्ट वे. And barium oxide, strontium oxide, calcium oxide, magnesium oxide, beryllium oxide, उसमें anion constant देख रहे हैं and cation का size बढ़ रहा है ना, beryllium, magnesium, calcium, strontium, barium, सबका charge constant. जब तक charge constant है, radius is the deciding factor. Yes, Monica Gupta and Anuj Gope and Betu is there in the class today. Okay, so that which of the following has the highest lattice energy, highest stability? Lattice energy is directly proportional to, stability is directly proportional to lattice energy, right? So these are the key points, my dear student. Third, इसमें charge है, सोडियम फ्लोराइड, मैग्नीशियम फ्लोराइड, अल्यूमिनियम फ्लोराइड. उसमें फ्लोरीन कांस्टेंट है एंड सोडियम का +1, मैग्नीशियम का +2 एंड अल्यूमिनियम का +3. So whenever the charge is variable, charge is the deciding factor. And ALF3 का ज़्यादा चल रहे हैं. Yes, of course, that's Ashok Solanki. That's good. I want you to please like the session. बच्चों, those who are online, please like the session. I am giving you the best out of the explanation for the NEET examination, and I am giving you the insight where you are going to get a question. Fine, any doubt? Please let me know. Moving ahead, I just want to say properties of ionic compound, basic properties. Van der Waals forces कब होगा? Let me finish ionic bond VBT, VSEPR theory, hybridization, molecular orbital theory, and at the end I want to talk about bond parameters and hydrogen bonding. There Van der Waals forces will come. There are near about 300 slides are there. Maybe we are at the slide number 20 or so. Please stay tuned in the class. आपको ज़्यादा देना चाहता हूँ. Okay? Monica Gupta. Sorry for inconvenience. Okay, Fazan rules भी होगा. Fazan's rule भी होगा. Okay, so soluble in polar solvents. Properties of ionic compounds. You take a common salt, put it in the water. You take properties of ionic compound. It is. दिमाग में क्या आना चाहिए? Table salt. And all the properties. Crystalline solids. The perfect crystal. Strong electrostatic forces. Soluble in water. They have high melting point and boiling point because the reason is the strong attractive forces between the cation and anion. Okay, we love to support you guys. Please ask any kind of doubts and you please click the link if you have any doubts and you put it your doubts in that link. Okay, and they are going to conduct electricity in aqueous and molten state. Ionic compounds are bad conductors in the solid state. Ionic compounds are good conductors in the molten state. Ionic compounds are excellent conductors in the aqueous state. And they exhibit isomorphism, polymorphism. I have a lot of doubt in the point number 4. How many of you have a doubt in the point number 4? Let us explore this point number 4. Ashok Solanki, let us drop everything and let us learn. Okay, it forms crystals in the solid state. Of course, solid state में crystal होता है, liquid में crystal नहीं होगा ना. Yes, of course, they are highly polar. Polar का मतलब charge is present, है ना? First drop. So let it be first drop, second drop. Okay. When you prepare for your NEET examination, you will become finally a very good doctor. ये डॉक्टर बनने के लिए कितना भी ड्रॉप लेना चाहता हूँ ले लो. 4 में डाउट है. Definitely, Ashok, you have the doubt in the 4. I will tell you isomorphism and polymorphism right now. So I will explain you. If you ask, I'll explain you. Definitely. So isomorphism is an excellent one. You see the different ionic compounds having similar crystal structure. Iron sulfate dot 7H2O. Magnesium sulfate dot 7H2O. Zinc sulfate dot 7H2O. You know white में color होता है ना, white vitriol. Magnesium sulfate, Epsom salt, green vitriol. These are all the different substances, but when you look at the crystal structure, they have the same crystalline structure. So they are said to be isomorphous. Same type of formula. They will have the same type of formula. NEET examination में which of the following are isomorphous? A, B, C, D, MCQ. Okay, Monica Gupta, you will be given A, B, C, D, all the above. Are you getting or not? Clear? That's perfect. This is about isomorphism. And let us see what is the polymorphism. You can see this is about the polymorphism. A compound can have different crystalline structures. Yes, you take an example. Zinc sulfide is an example. It exists in 2 types of crystalline structures. One is sphalerite, another one is wurtzite or wurtzite. Okay, now you can see this is the structure, looks the same, but they have the different structure. They have the different structure. You can see this part of this, you will understand. उल्टा दिखता है, एक crystal में उल्टा दिखता है. So that is a crystalline states and solid state. By God's grace नीट एग्जामिनेशन में हटा दिया, बट आयनिक कंपाउंड्स में सिर्फ आप पॉलीमॉर्फिज्म का डेफिनेशन पता होना तो अच्छा होगा बेटा। भगवान हेलो बेटा, एंड यू सी which of the following can show polymorphism? Simply you can straight away you can write it as zinc sulfide beta. ठीक है, very good. You understand the difference between isomorphism, difference between the polymorphism, right? Save. What do you want me to save? Aravali? Okay. Please make a discussion anything related to the current context and academics and no other kind of discussions. Please. Please, okay, because hundreds of students are attending the class. Now moving ahead here, hydration energy. Arre beta, what will happen? Energy released when 1 mole of a gaseous ion is hydrated in the large amount of water to form an aqueous solution. That is called hydration energy. So I said ionic compounds are soluble in water. When it is going to be soluble in water? Yes, take a glass of water and put sodium chloride in it. Yes, it is soluble. Because sodium chloride is a solid. When you put in the water, it is going to give sodium plus aqueous and Cl minus aqueous. So इसका पास hydration energy चाहिए. So the condition is whenever hydration energy is greater than lattice energy, जैसे compound soluble in water. Whenever lattice energy is greater than hydration energy, जिसका lattice energy ज़्यादा होगा, वो ऐसे compounds insoluble होता है. Insoluble in water. Are you getting or not? Clear? That's a very important. That please, my dear students, focus on the very informative concepts. Okay. So here is a collection of all students dropped and studying. Okay. Let us not make any cheat shot regarding that, and let us see the actual essence of the class. If the size of ion increases, hydration energy decreases. Charge on ion increases, hydration energy increases. As the dielectric constant of the solvent increases, मैं अभी हैदराबाद इन्फिनिटी लेन का यूट्यूब स्टूडियो से आ रहा हूँ भगवान बेटा, and more energy is released as a solvation energy. And this dielectric constant जैसे constant है, solvent का property है. Solvent has the ability to separate the cation and anion. That is given as a constant in the physics, that is called dielectric constant. Okay. So atomization energy bhi hoga, हाँ, definitely. We discussed that, and we see here solvation. So the interaction of the solute and the solvent molecule stabilizes the solute and the solution. If the solvent is water, then it is known as hydration. If this solvent is water, it is said to be hydration, and the energy is called as hydration energy. Hi, and dissolution of solute in the water depends on lattice energy as well as hydration energy. क्या होगा? If you dissolve sodium chloride in the water, sodium plus, and the water has a dipole, and the dipole is going to make an interaction here. That is what is called a ion dipole interaction. आयन डाइपोल इंटरैक्शन का वजह से ये सॉल्वेंट सोल्यूट का बीच में ये इंटरैक्शन होगा, एंड इट इज गोइंग टू बी, दिस इज एन इंपॉर्टेंट टॉपिक बेटा. ओके, नाउ मूविंग अहेड, कोवेलेंट बॉन्ड. कोवेलेंट बॉन्ड इज म्यूचुअल शेयरिंग ऑफ इलेक्ट्रॉन्स बेटा. हाइब्रिडेशन भी देना चाहता हूँ, जल्दी करना चाहता हूँ. दैट्स व्हाई माय डियर स्टूडेंट्स, स्टे ट्यून्ड एंड यू सी you have, it is formed by mutual sharing of electrons. If one pair of electrons are being shared, it is said to be a single bond, a dash. If two pairs of electrons are being shared, it is a double bond, two dash. and if 3 pairs of electrons are being shared, it is a 3 dashes and it's a triple bond. Okay, and dear children, let us look at this. Out of 1 pair of electrons can be given, okay, chlorine and chlorine, it is 1 electron being shared, ताकि इसका octet होगा, ये भी octet होगा बेटा, right? And 2 pairs of electrons are being shared. I don't want to give you the very basic of this chemical bonding, just intro करके आपको थोड़ा depth में जाना चाहता हूँ. Okay, Monica Gupta, right? Okay, Ashok, Solanki and Bhagwan, and please stay tuned. And Sonali, yes, double bond oxygen बीच में 2 bonds of electrons being shared, and nitrogen बीच में 3 pairs of electrons are being shared. Nr3 is greater than NH3, reason is solvation uses, sir. Yes, you can use this. And the theory is related to covalent bonding. What are the other theories we can see? You have various theories that we can say here: Cauchy-Lewis electronic theory, valence bond theory, VSEPR theory, and molecular orbital theory. And बहुत अच्छा animations भी है VSEPR theory के हिसाब से. Stay tuned in the class, okay? And we'll discuss every point of NF3 more dipole moment, dipole moment bond parameters में आ जाएगा. And you see here Cauchy-Lewis electronic valency theory. This is the first theory. Atoms combines by the transfer of valency electrons only, by sharing the electrons, okay? And only valence electrons participate in the bonding, but not the kernel electrons. To get the stable octet configuration, you have octet configuration, means 8 electrons, odd number jindabad, so 8 electrons. And you have duplet configuration, helium ka jaise, that is 2 electrons. Among octet and duplet is more stable as compared to the octet. So combining a atom contribute greater than or equal to 1 electrons to a shared pair equivalent bond and attains a noble gas configuration. So आपका जैसे fluorine you can see 8 electrons इसका, 8 electrons इसका, and you can say O2 forms 2 electrons being shared, so that you will be having octet, इसका भी मिलेगा, इसका भी मिलेगा. So we usually write this structure. This is what is called as a Lewis dot structure. ठीक है बेटा? And moving ahead, ethene. How to write ethene structure? You see carbon is having tetravalent. Carbon एक हाइड्रोजन के साथ, एक डॉट एंड डॉट. कार्बन एक हाइड्रोजन के साथ, एंड कार्बन टू कार्बन 2 इलेक्ट्रॉन्स इस दोनों का बीच में शेयर करने का कोशिश करता हूं, ताकि इसका कार्बन टू कार्बन एक डबल बॉन्ड है, एक सिंगल बॉन्ड है, मिलके के ऐसे स्ट्रक्चर बनेगा of valence electron bond cation and anion. These are the Lewis dot structures, we write it. Are you getting or not बच्चों? It's a planar molecule. Actually आप जो बोल रहे हैं ना मोनिका गुप्ता सही है, लेकिन जो लुईस डॉट स्ट्रक्चर का ड्रॉबैक होता है, ये शेप ऑफ द मॉलिक्यूल नहीं पता है चलेगा. सो ही कैन नॉट से, ही डोंट नो हाउ टू से द शेप ऑफ द मॉलिक्यूल, बट यू सेड यूर ग्रेट. बट ये शेप बोलने के लिए आपका VSEPR थ्योरी इस्तेमाल करना पड़ता बेटा. ठीक है, that's good, you said correct, but Lewis don't know that. Now moving ahead, formal charge बहुत important चीज का है. And so many students, when it comes to total chemical bonding में, when it comes to lattice energy, formal charge, dipole moment and van der Waals forces, you will be having kind of difficulty. Is it or not? Limitations, yeah. So let's talk about the formal charge. Charge on the formula is called as a formal charge. It's a theoretical charge over an individual atom or a molecule or an ion. That is about the formal charge. Okay? So what is the use of the Lewis dot structure? Actually, the structure of the molecule you need to know. Okay, so we don't know that Lewis structure is not correct. It's correct only, but its actual 3D picture is not given. It's a 2D picture. And you know, in a polyatomic ions or molecules, the net charge is possessed by the whole ion. Right, beta? And you know, the feasible to assign a formal charge on each atom. So the Lewis structures what we are drawing, especially in the case of resonance, all the structures we write as a imaginary and a hypothetical structure. आप जो स्ट्रक्चर बना है ना, ये सही है कि नहीं है, ये फॉर्मल चार्ज मेथड इस्तेमाल करके आप कोरिलेट करना चाहता हूँ. What is the use of Lewis dot structures? That gives you the actual picture about the chemical bonding. So moving ahead, the formal charge, you see formal charge on the oxygen. This is the structure and it is resonating. Atom number 1, atom number 2, atom number 3, and it can give you its resonating structures like this as well. This is also possible and this is also possible. When it comes to the formal charge on the oxygen is going to be -1, and it is going to formal charge on the atom 2 is +1, and formal charge on the 3 is going to be 0. So it is used to give relative stability of possible Lewis structures. That is the actual use of studying these formal charges. बच्चों, lowest energy structure पकड़ना पड़ता है, which has more stability and the smallest formal charge on the atoms. And this gives you an impact on writing various resonating structures, बच्चों. And it helps us to understand the actual version of the which structure is actually required. So to make it, you see limitations of octet rule. Molecules with incomplete octet is also possible, but Lewis octet rule. So octet rule means Lewis octet rule, better you say. He cannot explain such a molecule, beryllium chloride is stable, is formed and it is present in the laboratory. And 4 valence electrons are there. You can see 1 electron given chlorine, beryllium 1 electron and beryllium 1 electron and chlorine 1 electron. And of course it has a 4 valence electrons. And BF3 it forms 6 electrons over here. It is less than octet. Hypovalent you can say. Hypovalent compound means electrons around central atom is less than 8. But these are stable. How come these are stable is not explained by Lewis theory, right beta? But they explain. And first of all, how? He cannot explain why they are stable. It has its own limitation. It's a limitation, defect and drawback. समझ में आ रहा है क्या बेटा? Moving ahead, limitations of octet rule beta. Molecules with odd number of electrons भी नया explain किया. Which of the following has odd number of electrons? NO, NO2, Cl, O2, Cl, O3. Sir, you can see the structure odd electrons. हमेशा electrons जो है molecule में जोड़ी जोड़ी रहता है. Okay, electrons always exist in the pair. Let it be a bond pair or a lone pair. But the thing is here it is going to be odd electrons. What is the meaning of an odd electron? See, nitrogen, its valency is 5. Oxygen, its valency is 6. दोनों मिलके आपको 11. It's an odd number. So it is an odd electron species. Tour भी है. Enjoying the tour and enjoying the class. Wonderful. And hypervalent molecule जैसे molecule में central atom का 8 का ऊपर electrons होना चाहिए. Say an example, PCl5, you can see 10 electrons with the phosphorus. So this is what is called as a PCl5, which has 10 electrons. Still PCl5 is a stable, and Lewis cannot explain electron deficient compound. Lewis cannot explain odd electron species. Lewis cannot explain hypervalent molecule, right? These are the defects in this Lewis octet rule beta. तो क्या करना, limitations of octet rule, formation of compounds given by xenon and krypton. Yes, there are certain molecules xenon forms certain compounds, he cannot explain it, and it does not account for the shape of the molecule. Okay, Monica Gupta, he cannot account for the shape of the molecule, right beta? And xenon and krypton forms compound XeF2, right? You see, does not explain about the relative stability, which is more stable, which is less stable. ये दोनों का अंतर क्या होगा? These are not explained by octet. You need to know the theory. ये बोलना चाहता हो क्या, ये नहीं बोल सकता हूँ. And this is the way you need to understand chemistry and you explore chemistry. अगर एक्सप्लोर करने के बाद आपको पता होना चाहिए ये MCQ दे सकते हैं तो ये लिमिटेशन में होगा नहीं होगा, राइट बेटा? नाउ मूविंग अहेड, वैलेंस बॉन्ड थ्योरी, and these two grandfathers, Louis Pauling and Slattery, has given this VBT. Okay, make a salute. So they have given the concept of overlapping. Monica, so according to VBT, a covalent bond between two atoms are possible when orbitals of the bonded atoms come and overlap. That gives you a bond. That is called valence bond theory. A covalent bond is formed by the overlap of half-filled atomic orbital that yield a pair of shared between two bonded atoms. That is called as a definition of a covalent bond according to Linus Pauling and J.C. Slater. Right, beta? And I made a lot of efforts to say. And what is the meaning of the overlapping? All orbital overlapping do not result in the bond formation. Now, एक question पकड़ना का संभावना है. So that's a very important. You have a positive overlapping. Let us say this is the overlapping orbitals. So if this is a positive and this is the positive, and this is called a positive overlapping, and the bond will be formed, and this is also a positive overlapping. This is also a positive overlapping. The overlapping actually which gives the bond is called as a positive overlapping. That could be between a positive end of a lobe and a positive end of a lobe, and a negative end of a lobe and a negative end of a lobe, and that is called as a positive overlapping. जैसे positive overlapping में आपका bond देना है, it forms a bond. That's a very important. NEET में ऐसे questions आने के संभावना है. You are going to get a question based on this. What is a negative overlap? When overlap takes place, between a positive lobe and a negative lobe is called as a negative overlap. दोनों cancel करके ऐसे bond नहीं form होगा. ठीक है, zero overlap क्या होगा? The overlap between two orbitals which never be possible. Like you see, when you take this and this, okay, this is not the way to form a bond. When you talk about this, this is not the way to form a bond. So the inconvenient direction of the bond is called zero overlap. You have three kinds of overlaps. Positive overlap, जैसे bond पक्का फॉर्म हो सकता है. नेगेटिव ओवरलैप बॉन्ड कभी नहीं फॉर्म होगा बिकॉज पॉजिटिव नेगेटिव इज गोइंग टू बी न्यूट्रलाइज्ड. हियर इट इज गोइंग टू बी improper angle, improper direction. So I mean to say, according to VBT, the overlapping orbital should be in a proper direction and a proper orientation. Weightage on the bonding. So definitely you are going to get one question from any competitive examination based on this directly, and based on these principles of chemical bonding beta, you will be having four questions from other allied chapters. And moving ahead here, bacho, types of overlaps. Now you have axial overlap and lateral overlap भी है. So it forms yes and it forms no. Bond form होगा, bond form नहीं होगा. ठीक है बेटा? That's good, wonderful. So any more doubts? So in the NEET examination, which of the following is a positive overlap? Which of the following is a negative overlap? Like that questions will be asked. Are you ready to do the questions? Then a covalent bond, directional properties of the bonds. A covalent bond, it has a direction. It has a direction. And ionic bond has no direction. Because it has no direction, it cannot form spatial isomerism or stereo isomerism. You want my number? डिस्क्रिप्शन बॉक्स में टेलीग्राम लिंक है ना, उसमें मुलाकात करो. डेफिनेटली आई विल बी इन कॉन्टैक्ट विथ यू. दैट टेलीग्राम चैनल इज विथ अस ओनली. ओके बेटा, टेक केयर. I am there. If you have any doubts, you can ask as well in the doubts app as well, and we can all interact, okay, and we can explore academic excellence with infinity learn. Better moving ahead here, the covalent bond versus ionic bond, it is going to be an excellent outcome of this animation, right? क्यों क्लास के बाद क्लासेस होते रहता है बेटा, हमको टाइम नहीं मिलेगा. टेलीग्राम चैनल में एक बार मैसेज करो, आपको मैं वापस रिप्लाई कर दूंगा. ठीक है? सो कोवेलेंट बॉन्ड इज डायरेक्शनल एंड आयनिक बॉन्ड इज नॉन डायरेक्शनल. यू लाइक दिस स्लाइड? एक थम्स अप एंड फायरी इमोजी बेटा. कितना बच्चा है रे बेटा, राइट? Okay, now moving ahead. So coordinate covalent bond, यहाँ पर हमको ज़्यादा डाउट्स होगा. गुड मॉर्निंग. ओके, 𝒂𝒂𝒂𝒊𝒕𝒊𝒆𝒔. So please like the session. So it is actually a special type of a covalent bond. So if I say coordinate covalent bond is also said to be additive bond, and all the properties related to the covalent bond is nothing but coordinate covalent bond. मैं क्या बोलना चाहता हूँ आपको? हाँ, हलचल चल रहे हैं ना? अच्छा, हालत कैसे, पढ़ाई कैसे? हाँ, क्वेश्चंस भी देना चाहता हूँ कॉन्सेप्ट करने के बाद. मोनिका गुप्ता, कॉन्सेप्ट करने के बाद. ओके, दिस इज वन शॉर्ट सेशन. In that first we deliver the concept. ठीक है बेटा? Now we see it's a special type of coordinate covalent bond. कोऑर्डिनेट बॉन्ड. सो एक्चुअली कोवलेंट बॉन्ड में दो एटम का बीच में एक एटम एक इलेक्ट्रॉन देते हैं और एक एटम एक इलेक्ट्रॉन देते हैं. सो म्यूचुअल शेयरिंग होता है. ये कोऑर्डिनेट कोवलेंट बॉन्ड और डेटिव बॉन्ड भी होना. ये दो एटम का बीच में एक पेयर ऑफ इलेक्ट्रॉन एक ही एटम देते हैं, लेकिन ये पेयर ऑफ इलेक्ट्रॉन दोनों एटम शेयर करते हैं. This is what is called coordinate covalent bond. Only one of them two atoms. So it's a special type of covalent bond in which one atom contributes a pair of electrons so that two atoms are going to share. This is what is called coordinate covalent bond. In that you can say, so how to identify coordinate covalent bond? How many of you have this question? How many of you have this question? Now you can use the chat box generously. And we will discuss this. Arre beta, 𝒂𝒂𝒂𝒊𝒕. Bacha, you're all busy with your gaming and other mobile apps, and focus on the academic stuff, and please don't inculcate a culture in any social media like the bifurcation biased system like south, north, east, west. No, this is not we are raising India. We are all the best citizens of India, we will do the best for the nation, right? Coordinate bond on a compound में लेना है. Yes, कैसे लेना? Directional, different covalents than usual, तभी ये coordinate covalent bond होगा. And ऑक्सीजन का वैलेंसी 2 होगा ना, जब 3 होता है ना, extended covalency can seen, no problem. And presence of a covalent bond, this is the key point beta. No need to sorry please, no need to sorry please, right? Now in the social media, dear children, we are on Instagram as well, okay? You can just follow through social media, we will have a professional connect, right beta? So this is the key point that you can say how to identify a coordinate covalent bond, right? Class 10 में अरे बेटा you are working on games, you are working on South India, working on North India, क्या हलचल चल रहा है? Okay, who is telling you is North Indian, South Indian, okay, Northwest, okay, Northeast? No. You have set a timer in Instagram, ये भी कर सकते हैं? Okay, I will set for my son. Instagram में time लगा सकता है ना? Definitely. ये मौका है? Okay, let us do it. So, in order to do excellent in your competitive examination, just keep away your social media beta. That is the first medicine for the practice. Because people are opening the mobiles and doing the solutions, okay, and finding the solutions in the Google, which is not actually correct. Do it and strike it, you will understand. So you can Google it and you can use ChatGPT for exploring the things, okay. Don't use Google and ChatGPT for learning process. As a teacher, I am giving you this, okay. So I have hundreds or thousands of students as I adopted as a child. Sonali Gope, if the name is given immediately, your name is Anuj Gope, you are from Madhya Pradesh, I said na. So people don't know that, but I remember about you. Okay, you are preparing JA examination, but still you are attending the NEET channel classes with me. Okay, so what not everything I can tell about you. You are an arty student and you talk about idli sambar and you talk about very good concepts in chemistry as well. I know that. Okay, आप बुरे नहीं है. So such an awesome student. But बच्चे लोग ऐसे होते रहते हैं ना. So it is our responsibility to educate them. So बच्चों, I am telling you here by using YouTube channel, we are giving you the best out of the content. In order to learn this kind of awesome lectures, you need to go to a coaching center and spend thousands of rupees and travel together. But here, this YouTube channel, and you can enjoy this lesson for free of cost. Can you believe it? This is an awesome and super chance. Please use it. So हम बच्चा के लिए कुछ भला करने की कोशिश कर रहा हूँ, and you please do favor to us. Nothing, simply please like the session, share with your friends. इन लोगों को पे फायदा होना चाहिए, and please subscribe to Infinity Land NEET YouTube channel. Right, now here you can see fourth bond formed by the nitrogen is always a coordinated covalent bond, and you can see N2O. You can see N2O nitrogen is forming 4 bonds. So ताकि ये जो bond है ना, ये one bond is going to be coordinate covalent bond. You can just show like this. And the third bond formed by the oxygen is always a coordinated covalent bond. You can see here oxygen, hydrogen. This bond is called a coordinate covalent bond. So ऑनलाइन में डिस्ट्रैक्शंस बहुत होता है ना. ऑनलाइन में डिस्ट्रैक्शंस नहीं होगा बेटा. ओके, ऑनलाइन में डिस्ट्रैक्शंस यू आर डिस्ट्रैक्टिंग. ओके, इफ यू आर स्टबर्न, डिस्ट्रैक्शंस में बहुत कम आता है. यस, बिलीव मी. यस, नाउ And talking about Lewis acid and Lewis base, इलेक्ट्रॉन पेयर लेने वाला है लुईस एसिड होता है, इलेक्ट्रॉन पेयर देने वाला है लुईस बेस होता है. Ionic equilibrium Lewis acid base theory. Now I want to say lone pair donor called Lewis bases, lone pair acceptor called Lewis acids. Now you can see NH3, it's a electron pair donor, इसके पास electron है, lone pair of electron. Hu plus है, it is an acceptor, it is going to donate a pair of electron, you are going to donate an electron pair from here to here, so that you are going to have NH3 like this. Now I want to show you the coordinate covalent bond. H2O oxygen has an electron pair given to H plus, so that you are going to have a dative bond. Hydronium ion. Are you getting or not? You are an introvert and very shy guy, सिर्फ ऑनलाइन में ज़्यादा जोश चलता रहता है. Okay, I know that you are a very good guy. I only मैं आपको तारीफ दिया ना. Okay बेटा, Monica Gupta, you did not like my session. You please like the session for me. Please like the session. Now moving ahead. Now H2O, इसका पास जो इलेक्ट्रॉन है ना H प्लस का प्रोटॉन का इलेक्ट्रॉन देके H3O प्लस बनेगा. राइट बेटा? एनी डाउट? Now moving ahead, sigma and pi bonds. Covalent bond is two types. A covalent bond is formed by the overlapping of the orbitals. If that is an axial overlapping, that is called as a sigma bond. If you like it, na, that like it comes. If it is a lateral overlapping, na, it is called as a pi bond. So coaxial bond. So this is what is called coaxial bond. जो bond है ना, that is called as a sigma bond. And lateral overlapping है ना, this is called lateral overlapping, and the bond between these two is called as a lateral overlapping. Right, beta? Nice. Now let us talk about axial or head-on overlapping. And cylindrically symmetrical about the internuclear axis can undergo rotation about this internuclear axis. मान के चलो ये internuclear axis है. This is the nucleus and this is the nucleus, and the sigma bond that is formed is going to be like this between two p orbitals, and it has a cylindrical symmetry beta. आपको दिखता है cylindrical symmetry, it comes like this. You understand, this is what is called cylindrical symmetry. 88% in 10th, very good, congratulations. Generally pi bond between two atoms is formed by addition to sigma bond. मैं क्या बोलना चाहता हूँ, पहले sigma bond फॉर्म होना चाहिए, बाद में pi bond होगा. Without sigma bond, pi bond फॉर्म नहीं होगा. We got it, 92, Monica, very good, congratulations. And I want to say a sigma bond. जैसे सिग्मा बॉन्ड s ऑर्बिटल का बीच में भी हो सकता, p ऑर्बिटल बीच में हो सकता, s ऑर्बिटल p ऑर्बिटल बीच में होगा. राइट, 11th 93. एंड यू नो हाइड्रोजन जो है ना, s ऑर्बिटल में एक अनपेयर्ड इलेक्ट्रॉन में s ऑर्बिटल अनपेयर्ड इलेक्ट्रॉन, टू s ऑर्बिटल जॉइन टुगेदर, दैट इज कॉल्ड s sigma bond. Stay tuned, I am going to talk about the back bonding as well once hybridization is done. Now let's talk about the sp overlapping and s orbital and p orbital बीच में axial overlapping होता है, that is called sigma sp overlapping, and sigma is strong and pi bond is weak, and p orbital दोनों मुलाकात करके इसका sigma p overlap बनेगा. Right, madam? Now moving ahead, any doubt? So you can see pi bond. So pi bond is formed between two orbitals, so sidewise overlapping, that is called lateral overlapping, is called as a pi bond. And p ऑर्बिटल बीच में ओवरलैपिंग हो सकता है, that is called as a pi overlapping. This pi overlapping can be seen like this as well. And p ऑर्बिटल and d ऑर्बिटल बीच में आपका lateral overlapping भी हो सकता है, that is called p pi d pi overlapping. And you will see this third period elements will have this kind of bonding. And d orbital बीच में bonding होगा, that is what is called as d pi overlapping. Thank you Anuj, thank you very much. And types of pi bonds. So this is possible in the case of third period elements, and third period elements only can form, and second period elements do not form this. And talking about in general order, sigma bond is more stronger than pi bond, and the greater the extent of overlapping, more will be the bond and its strength as well. Delta bond we have, but we don't study here. We have only sigma bond and pi bond. Delta bond we don't have in the 11th and 12th at the level of NEET. So delta bond is not in our syllabus. And for the same value of n, जब तक n value constant है, pp sigma is stronger than sp sigma is stronger than ss sigma. Okay, this is about the strength of the bonds beta. And strength of pi bonds, 3p is less than 2p. So bond strength or bond energy is directly proportional to 1 by n shell number. ठीक है बेटा? Any doubt? बच्चों, so it is a long session. If required, we can have a 5 minutes break, fine, so that we can start hybridization after this. हाँ, या डर लगता है जनवरी के एग्जामिनेशन because of direction in nature. Can we have a 5 minutes break? जल्दी, quick 5 minutes break. If you say yes, I'll give break. Yeah. So बच्चों, we'll take a 5 minutes break exactly. And you know 285 slides, 50 slides भी भरा नहीं अभी तक. Okay. So we'll start a break. We'll meet exactly at 5 minutes. Bacha, I am back here. Thank you very much for waiting here. Friction nahi hai. So let's see the back. Bond strength. So when the class is not there, you guys shorting like a short rate, it increases up to 9. Very good. Nice. समझ आ गया. Now you can see there is a bond between s orbital to s orbital to form H2 molecule sigma s overlapping. Sigma 1s. Hi Betu, how are you? I was waiting for you. I called you 2 times. I couldn't find you. So finally you joined. So right. So let's see here. Oxygen to oxygen. You are going to see a bond between 2 oxygen atoms. In that a sigma bond and a pi bond is seen. A sigma bond and a pi bond between this, a sigma bond and a pi bond. ये दोनों में एक sigma होगा, एक pi होगा. Okay. You are discussing something other than this. Now talking about the nitrogen, उसमें एक sigma होता है, कि pi होता है, कि pi होता है, क्योंकि 2p1 2 3 2p3 की वजह से. So nitrogen to nitrogen, a triple bond is same. px py pz or pz px py. So internuclear axis supposed to be an z axis. It is conventionally taken like that. Okay. Okay, you updated now. Congratulations. Let us talk about limitations of VBT फिर भी. So I just want to do it so little quickly about this. So paramagnetic in nature of oxygen could not be explained by VBT. So when you take oxygen, put it in the magnetic field, the oxygen is going to be deflected. Okay, फिर Einstein. Okay, now why it is doing so? इसमें odd electron नहीं है. जब मॉलिक्यूल में odd electron होगा ना, इसका पैरामैग्नेटिक बिहेवियर आ सकता है. लेकिन VBT स्ट्रक्चर का हिसाब से ऑक्सीजन में इलेक्ट्रॉन जोड़ी जोड़ी भी होता है, ऑड इलेक्ट्रॉन कभी नहीं रहेगा. बट हाउ इट इज गोइंग टू बी पैरामैग्नेटिक इज नॉट एक्सप्लेन. So fails to account for the geometry and the shape of various molecules. Again, it is going to be a problem. Moving ahead, so steps to draw the structures, and directly we'll go into the next theory. So these are all again going to be, yeah, VSEPR theory. VSEPR theory, valence shell electron pair repulsion theory. This theory gives you insight for deciding shape of the molecule. So VSEPR theory, valence shell electron pair repulsion theory. The shape of a molecule has a lot of impact on its shape and its properties. So let's see, according to this theory, the central atom has the electrons in the outermost shell, and these outermost shell electrons always exist in pair. ये जो pair है ना, जोड़ी जोड़ी है ना, these are two types of pairs, a lone pair and a bond pair. The pair of electrons participated in the bonding is called as a bond pair of electrons. The pair of electrons which is not participated in the bonding is called as a lone pair of electron. And photosynthesis na ye oxygen has, or please focus on the concept here, dear children. So the shape of the molecules are based on how the electron pairs are arranged around the central atom. You know, bond pair is going to cause less repulsion, lone pair is going to occupy more space and more repulsion. The order of repulsions in this bond pair, lone pair repulsion on lone pair is greater than lone pair repulsion on bond pair is greater than bond pair repulsion on bond pair. So इसका वजह से ये इसका स्ट्रक्चर देना है. जनरल फॉर्मूला AB2, A is the central atom, B is the bonded atom, and electron pairs 2, bond pairs are 2, lone pairs are 0. It is going to be linear. It is going to be A and it is going to be B and it is going to be B, right? So it is going to be a linear shape, and 180 angle is seen. Example, beryllium chloride and carbon dioxide comes under this category. Monica Gupta, you are asking very good number of questions before the break. After break you are talking something other. Please focus here. Now you can say if it is AB3, 3 electron pairs होगा, geometry होगा इसका trigonal planar structure, and according to Ohm's law, okay, 𝒂𝒂𝒂𝒊𝒕, this is a chemistry class, we are talking about Ohm's law, which is not actually acceptable, है ना? आ रहा हो? Hi. So let us not dissolve the interest of this. It is a trigonal planar and you are going to have 120 angle. Example, BF3, SO3, BCl3 comes under this. Arav, good morning. And talking about A, B to L, if lone pair is introduced, you are going to see the bond angle is going to be decreased. That it is going to be, the geometry is going to be given by the steric number, okay, but the shape is given by only bonded electrons. It is a bent shape or V shape or angular, you can say. Example, SnCl2, SO2. NCERT question, nearest equation be, arre beta, no, no, let us focus on the current context. बच्चों मेरा आवाज सुनाई दे रहा है क्या? प्लीज बेतु मेरा आवाज सुनाई दे रहा है क्या? Right. Now let us talk about steric number VSEPR theory दोनों को मिलके. So steric number 4, it is supposed to be sp3, it is supposed to be ab4. It is supposed to be 1 less than. Whenever lone pair is coming, the bond angle is expected will be less than expected. ठीक है बेटा? Thank you. Please focus. Please focus. Right बेटा? So bond angle is equal to 109 degrees 30 minutes or 109.5, 109.5. And example CH4 NH4 plus xenon tetraoxide. And bond angle is going to be tetrahedral angle, that is 109.5, and the shape is going to be tetrahedral shape. क्या करना बेटा? Let us see. General formula AB3LB हो सकता है. Steric number 4. Geometry is going to be tetrahedral, but it is going to be a lone pair की वजह से it is going to be decreased. So it is going to be pyramidal. Bond angle is decreased. Example like NH3XO3 comes under this. sp3 is going to be tetrahedral. Here sp3 is absent. And also quickly is AB2E2 or AB2L2. A is a central atom, 2 bond pairs and 2 lone pairs. फिर भी sp3 hybridization होगा and it is going to have 2 bonded electrons. So 2 bonded के वजह से it is going to be angular or bent shape, you can say. Yes, you can experience some questions here. O2, F2, H2O comes under this category better. And AB5, it is going to have AB5 trigonal bipyramidal, 5 bond pairs and 0 lone pairs. In this TGBP, you can say TGBP or TBP, and it has this a triangle. On the triangle एक pyramid है, एक pyramid नीचे है. So this is called axial bond and this is called equatorial bonds. 3 equatorial bonds हैं and 2 axial bonds हैं. 3 equatorial bonds are strong and short, and axial bonds are going to be a long and it is going to be a weak. Example here it is going to be PCl5 is an example. Always TBP trigonal bipyramidal में there are 5 bonds, and these 5 bonds, all bonds are not equal. You can find 90 angles, 120 angles, 180 angles. In that, total number of electrons present in one plane is going to be 4 here. And you are going to see AB4L sp3d hybridization का और एक चीज़ है. You are going to see SF4 is an example, 𝑐𝒑𝒐𝒓𝒕𝒖𝒏𝒊𝒕 shape. It is going to be 𝑐𝒑𝒐𝒓𝒕𝒖𝒏𝒊𝒕 shape or distorted tetrahedron shape. Okay. Tetrahedral will show the geometrical isomerism coordination complex? No. If it is absolutely no in that case. Okay. That's good. 2 180 and 3 120. And you are going to see AB3L2. In this case, I could find a T shape CLF3. If you talk about the CLF3, in the same way, Cl, lone pair, you are going to have a bonded like this. ठीक है बेटा. F and F, इसमें bond कितना होगा? इसमें bond कितना होगा? Theta. Theta is going to be less than 90. That is very, very, very important. It is not 90, it is a less than 90 beta. So the bond angle is less than 90 and 180. CLF3 is an example. It is given clearly in the NCERT textbook. And also you can say AB2L3. In that 5 bond pairs, so 2 bond pairs and 3 lone pairs. You can see example like XeF2 is an example, linear geometry. You can see xenon. It has 1, 2, 3, 4, 5, 6 and a fluorine. sp3d hybridization में, and it is going to be linear 180 angle. So these are the very nice examples. Yeah, I3 minus. So how do I find a question based on this? Monica, when potassium iodide, iodine is soluble in water, insoluble, it is insoluble, है कि ना? But iodine, if you dissolve in the aqueous of potassium iodide, yes, it is soluble. कैसे? कैसे बेटा? आ रहा हो? द मॉलिक्यूल के ज्योमेट्री और शेप की डिफरेंस होता है क्या? ज्योमेट्री इज द वन वेयर हाउ इलेक्ट्रॉन्स आर अरेंज्ड, द इलेक्ट्रॉन पेयर्स आर अरेंज्ड, दैट इज कॉल्ड इलेक्ट्रॉन ज्योमेट्री. ये इलेक्ट्रॉन पेयर में लोन पेयर हो सकता है, बॉन्ड पेयर भी हो सकता है, बट शेप में सिर्फ बॉन्ड पेयर रहेगा. नाउ यू अंडरस्टैंड आ रहा हो? Now why it is soluble? क्योंकि I2 react with the potassium iodide gives rise K plus I3 minus. So जो I3 ना, it is going to have a linear shape like this. So logical questions भी निकाल सकते हैं NEET examination में. Are you getting or not? Clear? And moving ahead, steric number sp3d2 का 6 होगा. You are going to have SF6 an example. Dear children, sp3d2 hybridization में total number of electrons present in one plane you can say. So 1, 2, 3, 4, 5, right? And the bond angle is perfectly 90 all the way. Example is SF6 is such a stable molecule due to its perfect octahedral shape. The actual octahedral shape L2 you are going to have square planar. Understand? Clear? Any doubt? Now you have this is a square pyramidal, BRF5, BR, this is going to be F, and this is going to be F, this is going to be F, and this is going to be F, and this is going to be F. You can define a pyramid on the square pyramidal. So structure देखना कैसा है, ठीक है? And you have AB2 L2. So simply you have the square planar, that's it. So example XEF4, and also you see, and the bond angles you can see 90 and you are going to be 72. It is steric number 7 sp3d3 ab7 if7. This angle is very important, and you can say it is going to be pentagonal bipyramidal. Pentagonal bipyramidal is going to be very important thing. You can assume is a pentagon better. Can I show you a pentagon there? Yes, you can see a pentagon there. This is a pentagonal bipyramidal. Okay, beta. And moving ahead, need for hybridization. Yes, people have lot of doubts in hybridization. Don't worry, I have a simple formula to say hybridization. As you know, a covalent bond is formed by the overlapping of atomic orbitals. Yes, of course. But to form this bond, to overlap, the orbital present inside the atom may not be suitable for overlapping. So that the orbital present inside the atom before formation of overlap, before formation of a bond, it will reorganize itself, and it is going to form its new bond. So that reorganization phenomena is called as hybridization. You can say electronic shape of CH4 molecule is C. So carbon in ground state, it is 1s2 1s2 2s2 2p2. So 2 electrons are there, but to form 4 bonds with 4 hydrogen atoms, we need 4 unpaired electrons. So carbon ये जोड़ी इलेक्ट्रॉन एक्साइट करके ये 4 unpaired electrons form होगा, and these 4 unpaired electrons mix together, 1 s orbital 3 p orbital mix together to form 4 hybrid orbitals. Yes, so CH bond is formed by s orbital of hydrogen and p orbital of carbon. That overlapping angle between them is supposed to be 90. But fourth carbon to hydrogen bond will be formed by carbon S overlapping, which is actually not correct because this hydrogen atom cannot go inside the atom. So that is a need of hybridization. Now what I say, s orbital overlap can be in any direction because of its spherical in shape. So direction of the fourth carbon to hydrogen bond cannot be determined. It is not possible. That's the reason why what I do, I can go for the expected observation. The bond is going to be observed 109.5, which indicates there is a reorganization about the orbitals present in the CH4. So that is called. So there are 3 carbon to hydrogen bond formed by sp overlap or stronger than CH bond formed by the SS overlap, but all bonds are going to be same bond energy there. So that I just want to say, hybridization plus VBT together gives more complete theory to explain polyatomic molecule. So this is the limitation about the VBT. So we have to add, Linus Pauling is given hybridization concept and he extended, and you see Pauling and Slater, they extended this to explain the hybridization better. So this is a concept session, one short concept session we are running with a very good amount of concept. So it's a phenomenon of intermix of atomic orbitals of slightly comparable energies and reorganized to give rise same number of newly organized orbitals. These called as hybrid orbitals, and this phenomena is known as hybridization. You know, only the electrons, the orbitals present in the valency shell participate in this kind of reorganization, that is called hybridization. And before going for this hybridization, my dear students, I just want to tell you about NEET test series, a small promotional slide, and which has grade 11th and grade 12th and repeaters ko alag bana diya. It is prepared by eminent faculties from the content department, and it is actually related to NEET latest NTA pattern, and it gives you a real-time NEET examination taking experience. So in the description box, everybody just look into that and please go through it and you purchase this. When you purchase, want to purchase YouTube 30 of coupon code add करने तो आपको 30% slash मिलेगा. Just click it, automatically it will be applied. Okay, so I don't want to give you this as a super promotional. Okay, just for the advice you can take it. Okay, we are not selling anything on YouTube platform, just for students I am just giving you this. Okay, those 𝒂𝒂𝒊𝒕𝒊𝒕 and other students, please like the session. Arav, okay, who is that? Nayura, Preyu, okay, please like the session. Those who are online, please like the session. So moving ahead, so hybridization and the shape of hybrid orbitals. Whenever s orbital and a p orbital, 2 orbitals are mixing, it is going to form 2 hybrid orbitals. This is the nucleus of the atom beta, this is the nucleus of the atom. दोनों एक ही nucleus के साथ है ना. We usually get this number of hybrid orbitals like this. Actually the hybrid orbital shape will be like this, but we write the shape like this in the books when we write it, right? And the number of orbitals that are involved in the hybridization should equal to the number of hybrid orbitals that are formed. ठीक है बेटा? And you can see s orbital and n number of p orbitals gives plus m number of d orbitals, it is going to be spn dm hybridization of the orbital. So let's see the percentage characters and this properties and shapes ये आपको देना है sp sp2 sp3 sp3d sp3d2 sp3d3, ठीक है. सो उसमें क्या होगा, 1 s ऑर्बिटल 1 p ऑर्बिटल, 1 s ऑर्बिटल 2 p ऑर्बिटल्स, 1 s ऑर्बिटल 3 p ऑर्बिटल्स, 1 s ऑर्बिटल 3 p ऑर्बिटल, उसमें एक d ऑर्बिटल, 1 s orbital 3 p orbital 3 d orbitals sp3dt. I say so the name is self explanatory. Any doubt? Now let's talk about orbital can have a pair of electrons, have unpaired electrons, can be a vacant, can participate in hybridization beta. Right? And you can say promotion mean to say excitation is not an essential condition for hybridization. So I want to say here, which of the following is true as far as the hybridization is concerned? These are the various formats. These are the various statements that I can say. And orbitals undergo hybridization cannot the electrons. So number of electrons is always constant. Orbitals can undergo electron hybridization but not the electrons in it. And hybrid orbitals generally form a sigma bond. There will be 2 sp hybrid orbitals appears like this. So let's talk about the percentage of s character. Percentage of s character. So the number of s orbitals that are involved in this hybridization upon number of s plus p orbitals into 100. So sp hybridization, s का 50% है, p का 50% है, sp2 s का 33.33% है, sp3 का s का 25%. So students, let's see direction. So sp, sp2, sp3. So percentage of s character is a benchmark in hybridization and finding the acidity and the basicity. Or as s character increases, orbital becomes bulkier and shorter. Okay, Fauzia, I don't know Tamil, I know only Hindi and English. Please, thank you and follow. Energy of the hybrid orbital decreases, electronegativity increases. ये काफ़ी important चीज़ है. So the electronegativity is directly proportional to the percentage of s character. So ताकि इसका sp greater than sp2 greater than sp3 होगा. Understand? Clear? Right. Now you can see here percentage of s character in the hybridization increases. So stability of hybrid orbital increases and bond strength भी increase होगा. sp2p overlapping is stronger than, sp से p overlapping is stronger than, sp2 से p overlapping, sp3 से p overlapping it goes, because this is very important noteworthy point for the NEET examination beta. So decreasing order of bond strength, NEET examination is a noteworthy point. Everybody, any doubt? And hybrid orbitals are directional in space away to the minimum repulsions, right? In order to obtain a stable electronic arrangement beta, that is going to be a super awesome point. And this is a very important. NEET में MCQ आने का ज़्यादा संभावना भी है. अगर डाउट है ना तो आप लाइव चैट बॉक्स में इस्तेमाल करके आप पूछ सकते हैं. एनी डाउट बच्चों? कम ऑन बेतु, एक्सपेक्टिंग यू गिव डाउट्स. So moving ahead here, type of hybridization is estimated steric number. Steric number is equal to number of sigma bonds on the central atom plus number of lone pairs on the central atom. And this is the one way. And also you can calculate the steric number by V plus M minus Q by 2. Okay, you can say plus or minus. Okay, Q is the charge. So V is the number of monovalent atoms attached to the central atom. So V is the valence electrons. And M is the number of monovalent atoms. And Q is the charge. And reverse the sign. So based on this steric number, you can say your teaching is easy to understand. Thank you, Piyush. Thank you. Please like the session. Please like the session. And this formula can give you hybridization for anything. You can say, agar steric, by using this formula, you just find out the steric number beta. अब जब स्टेरिक नंबर पकड़ते हैं ना, स्टेरिक नंबर का हिसाब से आप हाइब्रिडेशन बोलते हैं. जब स्टेरिक नंबर 2 है, sp3, sp2, 4, sp3, 5, sp3d, 6, sp3d2 ऐसे होना है. गुड आफ्टरनून अनुज, यू आर बैक. लगे रहो. द शेप्स लीनियर, sp, sp2 trigonal planar, sp3 tetrahedral, sp3d trigonal bipyramidal, sp3d2 octahedral, and sp3d3 pentagonal bipyramidal. And these are the list of orbitals that are being used. Now d orbital जब आता है ना, तब आपको तकलीफ होगा. dz square होगा, sp3d2 dz square and dx square and y square, and sp3d3 dg square dx square y square dxy. Which d orbital can be used? That all depends. We are going more specific version of this usage of the d orbital in the complex compounds. Any doubt? Anush, now determination of type of hybridization. Orbital box diagram इस्तेमाल कर सकते हैं. आप फाइंडिंग द स्टेरिक नंबर मेथड भी इस्तेमाल कर सकते हैं. फॉर्मूला फॉर द स्टेरिक नंबर. दीज आर द 3 मेथड्स, एंड आई प्रेफर एनीथिंग as my convenience proceeds. And we can say participating orbitals, sp, it is going to be linear. Example, beryllium chloride. And sp2, we discussed this triangular planar triangular. One s and 2 p orbital. Hi, Mohammed Nadim. It is sp2, and talking about 1 s orbital and 3 p orbital gives rise sp3 hybridization, tetrahedral. Those who are online, please like the session. Please like the session. Okay. And you say here is the electron configuration of the carbon. We already discussed the carbon has the ability to undergo sp, sp2 and sp3 hybridization. So depending upon the type of the bond they form, they undergo that particular type of hybridization. Okay, in the TG-BP geometry, equatorial position has more s percentage occupied by the lone pair and multiple bonds. So you can use this trick. NEET में ये trick ज़्यादा काम चलेगा. Right? So in the TG-BP, if lone pairs are there, multiple bonds are there, keep it in the equatorial position. जब axial position में low percentage of s character वाला चलता है, so occupied by electronegative element. It is occupied by the electronegative element. Okay, that's very important. That is very, very important. Okay. हाय नदीम, टेक ए नोट ऑफ इट, थोड़ा सा हिंदी में दे सकता हूँ. सो दिस इज ए ट्राइगोनल बाइपिरामिडल ज्योमेट्री है ना. सो दिस इज द सेंट्रल एटम. जैसे जो बॉन्ड है ना इक्वेटर में जा रहे हैं, दैट इज कॉल्ड इक्वेटोरियल पोजीशन होगा. एंड जैसे बॉन्ड सीधा चल रहे हैं ना, दैट इज कॉल्ड एक्सियल पोजीशन होगा. ओके, सो व्हेन आवर हेटेरो एटम्स आर प्रेजेंट, जब आप लोन पेयर एंड मल्टीपल बॉन्ड आना चाहता हूँ, ये डबल बॉन्ड और लोन पेयर इक्वेटोरियल पोजीशन में रखना है बेटा, राइट. एंड यू नो आई एम गोइंग टू गिव यू इक्वेटोरियल पोजीशन में आपका एस कैरेक्टर ज़्यादा होना का बाद इट इज़ गोइंग टू बी शॉर्टर, छोटा होना है. एंड एक्सियल पोजीशन लो एस कैरेक्टर होगा, इसका वजह से ये लंबा होता है. So it is going to be longer and it is a weaker bond. Now you can say fluxional behaves as the PF5 due to the fast exchange between the axial and equatorial fluorine atoms. Energy difference between TGBP square pyramidal geometry and thermal energy is a different concept with term by pseudo rotation. So that's a different one, it gives you a little confusion. And you see here, this is SF4 and the lone pairs that are present here kept in the equatorial position of TGPP. XEF2, the lone pairs are kept in the TGBP and axial में होगा. XCOF2, lone pairs are present on the equatorial position. That is the key point I just want to say. So these are the structures where in the equatorial position or axial position, there you are going to get a question from the NEET examination. It's very, very, very important. Okay, clear? And bachcho, you can see sp3d2 hybridization. So you are going to have SF6 and sulfur is on excitation. You are going to see the s orbital, 3p orbitals and 2d orbitals milke. We are going to see sp3d2 hybridization. You are going to see the octahedral geometry. So no equatorial, no axial bonds are there in the octahedron. All bonds in the octahedron is going to be identical. Students has a misconcept based on this. So here also you will be having equatorial, here also you are going to have an axial kind of things, but such kind of problem is not there here. Got it? This is very, very important, sp3d2 hybridization. And also you see IF7, you are going to see sp3d3 hybridization. It is seen that it is a pentagonal bipyramidal. All structures with animations and geometry are being shown here. So Prayush, come on. Now in this case, hybridization of odd electron species, very, very, very important. So carbon free radical, it is sp2 hybridization, everybody knows. It is a planar trigonal geometry. But the thing is, sp3 hybridization is seen in the case of CF3 dot. Trifluorocarbon free radical is going to have sp3 hybridization. It is an exceptional thing. Okay, so keep a note on it, bachcho. Right, beta? Now, did you know PCl5, it is in the solid state. So competitive examination corner. So PCl5 सॉलिड स्टेट में क्या होगा, PCl4 प्लस PCl6 माइनस होगा, sp3d2 होगा. कॉम्पिटिटिव एग्जामिनेशन में ऐसे क्वेश्चंस आता है. PBr5 इन द सॉलिड स्टेट, it is going to have just sp3 hybridization. Okay, and Pi5 doesn't exist. ये मॉलिक्यूल एग्जिस्ट करते हैं नहीं बेटा. So P cannot accommodate 6 large sized bromine and iodine. So it cannot form PX6. Okay, and you see PCl6 minus is formed. Chlorine fluorine कर सकते but bromine iodine नहीं कर सकता. And the such a informative thing, and chemical bonding is connected to p block elements. So p block elements are studied by taking the reference of the chemical bonding. This is the best example I want to say. So in today's class we are talking about one shot chemical bonding. In the one shot chemical bonding, it's a marathon session, it goes 3 hours, more than that even, and we are going to have a wonderful discussion about an awesome subject with an awesome students. Okay, so let us, you need to have a very good patience to understand. Okay, and resonance, and you know organic chemistry में resonance काफ़ी बढ़ा दिया, and we will directly go into molecular orbital theory. Because maximum of the things are present here, bond parameters. After this we will go into the molecular orbital theory. Bond parameters, बच्चों, so the properties of the bond is assessed based on some measurable things, that is called bond parameters, right? So most of the p block elements content is tackled with the bond parameters. So in that I want to give you more emphasis on dipole moment. Betor, there in the class, come on. Right. So bond parameters includes bond angle, bond length, bond energy, and bond order, and bond polarity BA. Right. So let's talk about, so the bond angle means the angle made by, so this is the atom and this is the bonded atom and this is the bonded atom. The average angle made by two bonded atoms with respect to the central atom is called as bond angle. Okay. So it all depends upon the nature of bond here. So this gives an idea about the distribution of orbitals around the central atom. So the bond angle is basically decided by the hybridization. Now bachcho, here you can see the bond angle, yeah, hybridization. As percentage of S character increases, bond angle increases. So you can see sp3 109.5, sp2 120, and sp is going to be 180. Take a pen and paper, everybody write these noteworthy points. Bachcho, writing or not? Because bond parameters एक ही वक्त में लिखना है. Now this point number 2 काफ़ी important है, steric repulsions. And steric repulsions, what is the meaning of a steric repulsion? Repulsion by a bulky atom or a group is called as steric repulsion. As steric repulsion increases, bond angle increases, right? Same central atom second period का same hybridization होगा तो side atoms or in the third period atom onwards, you see as side atom का size increases, bond angle increases. Fluorine, chlorine, bromine, bond angle increases. Got it? This is a very, very important point. And you know, number of lone pairs on the central atom use only helpful only for second period elements. Okay. As the number of lone pairs increases, bond angle increases. Okay. Lone pair 0 है, CH4, bond angle is 109. Ammonia, lone pair is 1, bond angle is going to be decreased. Bond angle decreases. Water, lone pairs are 2, bond angle और कम होगा. Understand? This is very important. Do not use this for third period elements. Do not use it for third period elements. Okay. Now, electronegativity of the central atom. Electronegativity of the central atom increases, bond angle increases. So, OCl2, SCl2, SeCl2. Electronegativity decreases, bond angle decreases. For the same hybridization, number of lone pairs on the central atom. So, this is the noteworthy points. So, these are the noteworthy points you need to maintain with you. Fine, any doubt? And I want to say electronegativity of the side atoms, bond angle का इतना बड़ा points दे रहा है आपके लिए. Electronegativity of side atom increases, bond angle decreases. For the same central atom, same hybridization, same number of lone pairs के लिए ये point इस्तेमाल करो. ठीक है बेटा? So PF3, PCl3, PBr3, PI3. It is going to be increased. We discussed this, right? बच्चों, doubt है ना तो देना जल्दी. Quick. Now, moving ahead, point to remember, if you have a regular geometry, regular bond angle, all the side atoms are identical and there is no lone pair on the central atom, bond angle not affected by electronegativity. In these two categories, electronegativity is not influencing the bond angle. That's very important. And also, you see example here, carbon, CCl4, SaCl4, SnCl4, GeCl4, all are going to be 109.5. I want to say, which of the following has the same bond angles? So, this is the noteworthy point. This is the noteworthy point where you can get a question. एग्जाम्पल ऐसे होगा, ए बी सी डी ऑप्शंस की वजह से. समझ में आ रहा है बेटा? क्लियर? So I want interaction. This is a live interactive session. I'm expecting you to give the answers and I'm expecting you to give the questions as well. Any doubt? Now, factors affecting bond angle. If we have a back bonding, the bond angle is suddenly changes. Bonded atom to a bond is going from the bonded atom to the central atom is back bonding. Actually, we have some slides based on the back bonding and एक short video में back bonding के बारे में आपको discuss करना चाहता हूँ. And central atom to the side atom, if this is the case, you are going to see the bond. This is NBF3. It is going to be a back bonding. Okay, trisilylamine, it is supposed to be a pyramidal in shape, but the lone pair of electron on the nitrogen is given to the d orbital of the silicon, so that it is going to be a trigonal planar. ये डबल बॉन्ड भी एक बॉन्ड पेयर का जैसे देखना है VSEPR थ्योरी का हिसाब से. एंड बच्चों, and BF3 due to back bonding, bond order increases, but net effect in the repulsions are 0. So bond angle 120 होगा. But trisilylamine NSiH3 thrice due to p pi d pi back bonding, hybridization changes from sp3 to sp2 beta. So जैसा होगा, bond angle increases. 107 degrees to 120 बनेगा. Okay, so जैसे आपका this is going to be 120, bond angle increased. Got it? Clear? And also bond length. The average distance between two bonded atoms is known as bond length. Equilibrium distance between the nuclei of bonded atoms in a molecule, or average or equilibrium. So factors affecting bond length. So 1, 2, 3, 4, 5. First, size of the bonded atom and number of lone pairs on the bonded atoms, bond multiplicity and electronegativity, and the percentage of the S character. So these are the various factors that you can say. If you have a specific doubt in any one of the parameters, please let me know. I said this is a live interactive session. I want you to give the answers as well as questions in the live interactive session. So Betu, Monica Gupta and Anuj and Nadeem, those who are online, please a thumbs up and come on, let us see various factors. Bond energy. The amount of energy required to break 1 mole of a type of bond is called as a bond energy. Okay, if it is a diatomic molecule, you can say enthalpy of atomization. Thermodynamics में ज़्यादा emphasis किया. So the bond energy between carbon to carbon single bond, double bond and triple bond, you can see as bond multiplicity increases, the bond energy increases. Beta. Okay, it's a long session because of the cold weather, having kind of cough and cold, taking hot water, and I don't want to disturb you, give you the best out of the subject. Moving ahead, as bond length decreases, bond energy increases of the same type of bonded. Chlorine, bromine, iodine. Bond length increased and bond energy decreased. उसमें फ्लोरीन नहीं रखा क्यों? हाँ, yes, fluorine is kept here. Why so? क्योंकि फ्लोरीन bond जो है ना, and lone pair of electrons are close to them, so that the fluorine is going to have repulsions between these two. Betu, that's the reason why they have this less bond energy. And जैसे bond energy का ये जो order दिया ना, ये NEET examination का काफ़ी important है. So which of the following is expected? Which of the following is having highest bond energy among the halogens? Is chlorine. Lowest is going to be iodine. But you misunderstood. It is a fluorine is the highest, but it is not. Chlorine greater than bromine, greater than fluorine, greater than iodine. That is a noteworthy point. Please take a note of it. And bachcho, so larger the bond energy is said that it is supposed to be stronger is the bond. So hydrogen जो bond है ना, you have to break by using 435.8 kilojoules. Please don't memorize this value. आपको थोड़ा सा डेमो देने के लिए आपको. एंड ऑक्सीजन डबल बॉन्ड जो है ना, ये ब्रेक करने के लिए 498 इस्तेमाल किया. I mean to say here, so for a polyatomic molecules, enthalpy needed to break each bond between the same atoms is different. जैसे आपको मान के चलो मीथेन है, वाटर. ओके, सो ऑक्सीजन एंड हाइड्रोजन एंड हाइड्रोजन, ये बॉन्ड करने के लिए 502, ये बॉन्ड ब्रेक करने के लिए 427. सो ऑक्सीजन टू हाइड्रोजन बॉन्ड एनर्जी इज गिवन एज द एवरेज ऑफ दिस. So the total bond dissociation enthalpy is divided by number of bonds broken. So you have to consider the average bond energy beta. So it is going to be 464.5. Thermodynamics में हम सीखा है ऐसे. And you see the bond order. So the bond order resonance में पढ़ा and Now, bacho, here what exists in reality, the existence some covalent bond with ionic character. How it is possible? Because of the covalent bond is basically categorized into two categories. One is a non-polar covalent bond, another one is a polar covalent bond. So, what is the polar covalent bond? If the bonded atoms ka electronegativity is greater than 0.4 ka, okay, if it is less than or 0.4 between the atoms, okay, you can say the polar bond or a non-polar bond. So non-polar bond charges बिल्कुल नहीं होगा, polar bond charges होगा. So charges के वजह से polarity मिलेगा. ये polarity क्या है? If ये atom bond बीच में होगा तो ये जो electron bond जोड़ी है ना, ये खींचते हैं ना, ये atom भी खींचते हैं. So as a result of this, the bond pair is going to be staying there itself. So symmetrical electron cloud like hydrogen में होगा, chlorine में होगा, nitrogen में होगा, fluorine में होगा. But the thing is, if A and B का बीच में होगा ना, शायद मान के चलो B electronegativity A के ऊपर है ना, तो so B ये जो electron जोड़ी है ना, जोर से खींचते हैं. As a result of this, the electron pair of these is going come close to the B. So when it comes close to the B, so B is going to have little bit negative charge, shayad A will have little bit positive charge. This is called asymmetrical electron cloud. Electron cloud B ka upar zyada hoga. This is called bond polarity. You understand? This is called bond polarity. So a bond polarity dekhne ka kaise? This is called polarization. Due to the polarization, charged and developed. As a result of this, electric dipole is generated. HCl, chlorine more electronegative than hydrogen. Chlorine का ऊपर negative charge आएगा. Negative pole and a positive pole is developed. Dipole is developed. ये dipole अभी देखने वाले हैं अभी. So it is called dipole moment. So dipole moment is a measure of the polarity beta. So it is the magnitude is equal to the product of the charge and distance of separation. So what is this? This is a charge, no? So dipole moment is indicated with a nu is equal to, this is the magnitude of the charge dot, and this is what is called as a distance of separation. Okay, this is L. This is what is called as a dipole moment. He wanted to say it is indicated by nu. So when we open a chemical bonding concept, you will be having lot of confusions. One confusion starts with the coordinate covalent bond. Another confusion starts with the formal charge. And here is the dipole moment is one more confusion. How many of you agree with me? So if you keep quiet, how do I understand your doubts, bacho? How do I understand your doubts? Okay. Hope you are understanding clear. Nadim, Beto, Prayush and Anush. Right. So moving ahead. So the formula of dipole moment is given as nu is equal to Q into D. And nu is dipole moment and D is the distance and Q is the magnitude of the charge. It is measured in electron standard unit. And distance is measured in centimeters, and you see is a vector quantity. Dipole moment is a vector quantity. It is used in d by 1 d by is equal 10 power minus 18 ESU centimeter. ये काम ज़्यादा होगा. So 1 electron charge is equal to 4.8 into 10 to the power of minus 19 ESU. Okay, and vector quantity, it has a direction. It has a direction. You can see the directions here. Hydrogen and the chlorine. The direction should be given to its most electronegative atom. Right? So it is represented by a tail on the positive center and head pointing towards the negative center. And you see the value of dipole moment for a diatomic molecule, for a polyatomic molecule. For a diatomic molecule, the difference in electronegativity is, for a polyatomic molecule, it is the bond dipole and it is the 3D arrangement of the atoms, right? And you can see here, in a diatomic molecule, nu depends upon the difference in electronegativity, but that's it. For a polyatomic molecule, it depends on the shape, 3D shape. We have to look into the 3D shape of the molecule. Got it? So moving ahead for the resultant dipole moment, if this is an atom A and this is an atom B and this is an atom B, as it is a vector quantity, you have nu1 is the dipole moment, this is the nu2 is the dipole moment, and resultant dipole moment will be in this way. So resultant dipole moment aayega. You are very good at vectors in the physics, right? So resultant dipole moment is equal to root over, so nu1 square plus nu2 square plus 2 nu1 nu2 cos theta. This is what is called as resultant dipole moment. If resultant dipole moment is 0, such molecule कहता है non-polar. Okay, if resultant dipole moment is not equal to 0, it is said to be polar. Got it? It is easy to learn this. Array, this is and both are same, and the theta decides. As theta increases, na, resultant dipole moment decreases. That is an important point. So I am being a faculty of 25 years experience in the teaching all competitive examinations. I am giving you the exact pointer where you are going to expect a question, and you should be so sound in the subject knowledge, right? Now moving ahead, so generally out of Q and D, Q is the dominating factor, beta. You know that nu is equal to Q into D, okay, charge into D, whatever. So this is the deciding factor. As a difference in electronegativity increases, Q increases and resultant dipole moment increases. Okay, Prayush, for a non-polar molecule, resultant dipole moment is 0. For a polar molecule, resultant dipole moment is not equal to 0. Fine. And also the dipole moment for the diatomic molecule and the polyatomic molecule, talking about the polyatomic molecule, you can see it could be a 0 if it is a regular symmetrical geometry, like beryllium chloride, beryllium and chlorine and chlorine, and the dipole moment is going to be 0, dipole moment is going to be 0 here, resultant dipole moment is going to be 0. Because both forces are pulling towards opposite side. Right? Betu, come on. Moving ahead, regular geometries always will have 0 dipole moment. Fundamentally, regular geometries will have always 0 dipole moment. And TGBP also, regular geometries will have always 0 dipole moment. Understand? And you know, dipole moment, lone pair contributes in the dipole moment. You need to understand this. Lone pair contributes in dipole moment. Then you start some discussion here. But its contribution can't be quantified as size of the lone pair is not known. Super important point. Actually, this point usually teachers don't teach, rather based on these questions are done. Now the student end up with confusions. Let us block this confusion and dissolve this confusion and move ahead with this forward way. So dipole moment is going to be 0, symmetrical molecule, dipole moment is not equal to 0, it is supposed to be a symmetrical molecule. Now you can see here the magnitude of the charge on the electron, 4.8 into 10 power minus 10 ESU, ये क्या है? And we know that 1.6 into 10 power minus 19 coulombs, but it is also said to be electrostatic unit. This is 4.8 into 10 power minus 10 ESU. And 1 device is equal to, ये convention बहुत अच्छा है, 3.3 into 10 power minus 30 coulomb meter or 1 device is equal to 10 power minus 18 ESU dot centimeter. It is dimensional because it is a vector quantity. And predicting the geometry using dipole moment. CCl4. All 4 bonds are symmetrical and dipole moment is equal to 0. Fine. And CH3, all dipole moments are going to be 0. Carbon and hydrogen. Carbon is more electronegative. Carbon and chlorine. Chlorine is more electronegative. Understand? Yes. Pranav, you please mention your doubt. I am happy to, I am standing here for your doubts. Please, come on, jaldi. I really enjoy doubts. Come on. And CHCl3 is a chloroform. You know, this hydrogen to chlorine and hydrogen to carbon, carbon to chlorine. So, it is going to be not equal to 0, it is 1.0 for debye. Please don't memorize the value, it is shown to convince you. Pranav, I am waiting for your doubt. Now, CDF3, CD3F, CH3F. Always heavier isotope will have more dipole moment. Yes. I will, this slide you want me to explain or before that? This one, I am waiting for you. Okay. Carbon and chlorine. Chlorine is more electronegative, so that dipole moment will be in this way. Dipole moment will be in this way. Dipole moment will be in this way. Dipole moment in this way. Okay. So, 4 bonds are not, this is not a direction in that like this. It is a, this is not the direction. This is a tetrahedral direction. Okay. Tetrahedral direction means it is going to be like this, my dear children. Tetrahedral I want to show you here. It is 186 now. Yes. I want to show you here. Here it is going to be central atom here and a bonded atom, another bonded atom, another bonded atom, another bonded atom. It is going to be a tetrahedral in geometry. You can see this is going to be a tetrahedral. You can see 3-dimensional geometry is seen here. Are you getting on? 3-dimensional geometry is seen here. Clear? You got your doubt solved. Now, can you believe the bond angle here? You claim that is 90 degrees. No, the bond angle is going to be 109.5. Can you believe this? You can see all the bonds are going to be in this way. Clear? All the bonds are going to be in this way. Anyways, So, if you have a doubt, I am the first person to be very happy. Right, moving ahead. So, heavier isotope will have more dipole moment, so that CD3F is more dipole moment than CH3F, right? Because of the electronegativity, difference between carbon to deuterium is greater than carbon to hydrogen. So, you will be having assertion reasoning type. This could be assertion, this could be reasoning. So, dear children, in this level of subjects, we are exploring the super quality lectures, okay? And you can see dichlorobenzene, orthodichlorobenzene, metadichlorobenzene, paradichlorobenzene. This is the linear bond moment. We know that resultant dipole moment, okay, is going to be root over nu1 square plus nu2 square plus 2 nu1 nu2 cos theta. So, as theta increases, resultant dipole moment is going to be decreased. As theta become 180, you can see the theta become 180. Okay, is going to be 0. Here theta becoming 120 and theta becoming this is going to be 120, theta becoming 60. Are you getting or not? And also you can see cis 1,2-dichloroethene and trans 1,2-dichloroethene. So, trans is going to be 0 here. If this group and this group are same, trans is going to be 0. And also effect of dipole moment and boiling point. So, generally dipole moment increases, boiling point increases because intermolecular force increases. Boiling point of cis is greater than trans. And see you here, the percentage of ionic character also can be discussed here. So, the percentage of ionic character observed dipole moment upon theoretical dipole moment into 100. Observed dipole moment means exponential dipole moment value, and theoretical dipole moment means you calculated nu is equal to charge into distance. This is what you theoretically calculated, right? And this is exponential, right, Pranav? And also covalent character in ionic compound, it is explained on this basis. Okay, this is based on various polarizabilities and all, and we'll have a separate class based on molecular orbital theory, and also still 84 more slides are there. That's why I just want to talk to the conclusion here. Fazan's rule का एक and intermolecular forces का एक, I want to create 3 more short sessions for these 3 subtopics. Can we predict a molecular shape only from the dipole moment without drawing the structure? No, you can't do that, Pranav. You can predict the shape whether it is symmetrical or not. ठीक है बेटा? And my dear children, this is a NEET test series, the ultimate key to NEET success. It is separately prepared by 11th standard बच्चों का अलग है. Okay, it is separately prepared for the 11th standard का बच्चों का, and 12th standard का अलग है and repeater का अलग है. And whenever you are preparing for some examination, it is important to know where exactly you stand. For that, we Infinity Learn prepared a NEET test series, an ultimate key to NEET success. So, it is prepared by the eminent faculties from the content department, and it is based on the latest NTA examination pattern, and it simulates the real-time NEET examination experience. So, in the description link it is there, and you can just scroll down just below the my video right now, and you can click it and you can just go through it and if you want to explore and purchase and apply YouTube 30 off coupon code ताकि आपको 30% डिस्काउंट मिलेगा, right beta? And all the best. I am done for now. We will be having a short videos after this based on Fasan rule, based on molecular orbital theory and resonance behavior, and we'll do the best. And here I am done for my time because time is valuable and such a long duration of this session. Okay, thank you very much. Please like the session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye bye. See you.